Hi, in this video we are going over a procedure to find the derivative of function 1 over x to the x power. Now let's quickly recall that for any power function x to the n power, when you take the derivative function, all you do now is using the power rule, we bring down the power n and then subtract 1 from that. That's very easy. And then, or you are given a function where the variable x now becomes the exponent and we have the base as a constant, for example a to the x power, or maybe a can be any constant, maybe 2 to the x power. Okay, then when you take the derivative function, then that becomes a to the x, the same thing, and then multiply by ln of the base a. So either we get the variable x as a base or the exponent. But in this case, for this problem, the x appear in the base and also in the exponent place. So now we have the x on both the base and also on the exponent. So we couldn't use any of the two formulas here that you just saw. And then, for example, a few other type of similar function that the x appear on both the base and also the exponent. X to the 2x, the x is in the base and also in the exponent. Now the x is also in the base and the square root of x is also in the exponent place. The same thing here, and then also this one. So we see that anytime we see that the x, the variable is on the base and also on the exponents. So we cannot apply any of the rule that we just saw. And for this type of problem, we apply a trick to that by the general rule is we apply the trick, and knowing that any exponent e to the ln of something, you get back something back, because the ln has the base e, and the base e and the e here, they will cancel each other. So e to the ln, they will cancel each other. So all you get back, you get the argument inside the ln. So anytime that we take e to the ln of anything, the box here could be anything, you get back the box because e and the ln, they cancel out. So we apply this trick here to the function that we are looking to find the derivative function. And d over dx is finding the same thing as finding the derivative function of 1 over x dx. And here we're gonna apply the trick that we just talked about in this slide. So just for easy, I let y to be the function that we are solving for. So y to be 1 over x dx, 1 over x to the x power. And then I know that when I take e to the ln of anything, I should end up with the same thing. Therefore, this whole thing here is just the box in this formula. So I take I take e to the whole, the e to the ln of the whole thing here. Then I should get back 1 over x to the x power. It's because e to the ln will cancel out. So you get back 1 to the x power. So that means I don't change the function at all. We just rewrite it in another way using this formula. But they are basically the same thing. Okay. And we know that another property of the log function, where the log base b of any a to the c power, then we can always bring down the c power in the front of the coefficient of the log here. In this case, I know that x here is the power, and then I can also always bring the x to the coefficient in front of the coefficient of the log. In this case, ln is the log of base e. So I can always bring down the x here. That's why I change this one into e to the x ln of 1 over x. And the reason I do that because I can now take the derivative function of y and go back to the rule for e to the u power. When you take e to the u power, take the prime, that's you get back the same e to the u, but then don't forget to multiply by the chain rule of u prime. The same thing happened to here. Now this whole exponent here is u. So when I take y prime, then I get e to the u. The same thing. E to the same thing. And then multiply by the chain rule for the exponent, which is u prime. This is u. So u prime, take the derivative function one more time. And we are good for the first term here. And then you can see, to take the derivative function of the second term, we know that this is the product between x and ln 1 over x. So we must apply the product rule. So let's review the product rule. F times g prime. The first function take the prime times g plus the second function prime multiplied by the first function. The same thing here. In this case, so we keep the same first term, just carry it down. Now, there's two terms here. The first term represents for f, which is x. ln 1 over f is g. 1 over x is g. Now, using the product rule, the first function x take the prime, and then multiply by the second function, the normal second function. And then add to the second function, ln 1 over x take the prime, and then multiply by the first function, which is x. And now let's try to simplify that further. We know that when x, the derivative function of that is just 1 using the product rule. So that's become 1. And carry down the ln 1 over x. And the derivative function of ln 1 over x prime. Now go back to the rule for ln u. Take the derivative function of that. That's become u prime over u. So that's the rule in general. We already applied the chain rule here. So the same thing here. This is the u, which is 1 over x. So that should become u prime over u. So the u here is 1 over x. And then u prime, which is 1 over x, take the prime. And then we multiply with the x that we carried out from the product rule here. And then there's one more derivative here, 1 over x prime. So let's do it in the side way. 1 over x, take the derivative function of that. Now I move the x to the top and then put the minus 1 exponent. And then now using the power rule, take the derivative function and using the power rule, subtract 1 from minus 1, that's become minus 2. And then bring the minus 1 to the coefficient, that's become minus. And then I can bring the x back to the bottom, switching the negative exponent into positive exponent. So this term here is minus 1 over x squared. I need that to simplify the whole expressions. So I keep the y ln 1 over x here and plus 1 over x prime. Now I plug in minus 1 over x squared, which is on the top here, and then keep the 1 over x and then carry down the x here. Now we need to simplify this thing further. Again, I carried out the same thing over and over again, the whole first term. And ln 1 over x, I carried out that here. When you divide by fractions, we actually multiply by the reciprocal of that. So the minus 1 over x squared is here. Dividing by 1 over x is the same thing as multiplying by x over 1. And then keep the last x here. And then as you can see that from this step, we can simplify this into a simple expression. This is x, so x squared. So x squared and x squared at the bottom, they cancel out each other. So you have only 1 left. Okay? And then from here, we can further reduce this expression. The ln of 1 over x is equal to ln of 1 subtract the ln of x. This is the property for the log function. The logs of base b of a over c is equal to the logs of base b of a subtract the logs of base b of c. The division turns into the subtraction. This is the property of the logs. So I apply it here. ln of 1 subtract ln of x from this division. And then subtract 1. Just carry down the 1. Now we already know that the ln of 1 is 0. So basically the whole process here, the second term now has only minus ln of x and minus 1. And remember, this whole expression here now multiply together with the first term that we had before. And then from here, we finish the problems. So we continue with it here. So we finish the problems with further simplification. We can see that again, this is the derivative function, so I just write fy prime. So we carried out the first term, and the second term is minus ln of x minus 1. And then we can see that this term here, now I can bring the x back to the exponent. Before we move it to the coefficient, now we can bring it back, which is right here. The same rule. We can bring it down and also bring it back, the power rule of the logs. And then we can see that e and ln of e, we let that in the beginning to be e to the ln of that whole expression here. Now we just take that away, cancel that to simplify it further, because we need this to do the derivative function. But now after we finish everything, we should take away the e and the ln, so that we get back 1 over x to the x power. Okay, because you want the simple expression, so just cancel out these two. And then between these two terms, I can pull out a minus 1. So the first term, when I pull out a minus, there's no more minus, the plus. The minus 1 I pulled outside, so that's plus 1 remain inside. And then the reason I did that was because I can bring the minus to the outside, which is right here. And then we have 1 over x to the x power and multiply by ln of x plus 1. And this is the final expression. It looks very simple, and there's nothing we can do to further simplify the expression. So this is the expression for the derivative function of 1 over x to the x power. So anytime that we see the base and the exponent, they all contain the variable x, then we have to use the trick that e to the ln of that whole expression equal to the same thing. And then from there, we can apply the derivative rule for e to the u to find the prime, and then do the simplification and reduce the fractions or anything that it has, and get to the final answers. And make sure that at the end we do convert this one back to the original expression. So take away the e and the ln at the end, the last step. Okay, so that's how you solve the problem for the derivative function of 1 over x to the x power. And thanks for watching.